To summarize then what we have mentioned so far in our discussion, when we are comparing computers, what are the questions we need to ask? How many cores does a CPU have? In general, the more is the better. Also, how big are the caches? Sometimes you really have to dig for this kind of information. Expensive servers generally have larger, faster, and more expensive caches. Cheap caches are the hallmark of cheap computers. What is the clock frequency? These numbers don't compare across architectures or vendors, since the number of cycles required to do a single instruction is likely different. However, it can still be used to compare otherwise identical CPUs. How much memory and storage does a computer have? Note that the memory is typically volatile, and that means that it is erased when the power is turned off. When the computer is off, only the data on the disk is preserved, and we generally use the terms memory and storage to refer to RAM and disk respectively. Memory and storage capacity are measured in multiples of bytes, which are themselves multiples of 8 bits. We will talk much more on this in a minute. The abbreviations that you see in the parentheses refer to kilobyte, megabyte, gigabyte, and terabyte, which are 1,000, million, billion, and trillion bytes, respectively. To add to the confusion, the memory capacities are actually rounded up to the nearest power of 2, while the storage capacities are expressed in the usual base 10 notation. Finally, what peripherals does this machine offer? And what do you actually need? This last slide gives us an idea for the different memory and storage capacities and how actually those numbers are computed. For instance, 1 byte is defined as 8 bits. 1 kilobyte is 2 to the power of 10, 1 megabyte 2 to the power of 20, 1 gigabyte 2 to the power of 30, 1 terabyte 2 to the power of 40, so we go up by 10 every time. In the third column you can also see the relationship between the powers of 2 and approximate powers of 10. Good things to know: 2 to the power of 10 is about 1,000, 2 to the power of 20 is about 1,000,000. Note that 2 to the power of 32 is about 4 gigabytes, which is the directly addressable address space limitation for 32-bit computers. We will come across this number later in the lectures. You can keep it in mind now, but we will explore it more later. Now, on the last column, we have some practical measures to get an idea of how big or small these sizes are. So about a megabyte is a minute, for example, of MP3 music. Now, regarding the terabyte measure, 80% of a human's memory capacity, this is an estimate that comes from Ray Kurzweil. He is a futurist and promoter of the singularity concept. If you're interested, you can look up more about him. And this is again an estimate based on how many people are on Earth and what is the memory capacity, the combined memory capacity. These are just some numbers to give you an idea.